Jason is our chief architect here at Weave. He's the one that brought us the Go language when he very first came, and he's also the one who helped pioneer the use of cloud-native technologies like Kubernetes here. So he's got a wide array of knowledge, and he's presenting today on Jaeger Tracer. So I will let him take it from here. Thanks, Jason.
Awesome.
Is your mic
Thanks.
on?
Is it? Yep.
Okay.
It's on. Cool.
Oh, one last thing. Sorry, Jason. When someone has a question, we're going to throw them the conch shell. Okay? It's a mic. So then you have to talk into it. But there's some sort of like motion thing in it to do noise canceling. They don't want you to get like when you catch it to make noise. So when you catch it, count to like 2 and then ask your question. We're giving it a trial. We're giving it a trial. Just bear with us for one time. We want to see how it goes. But we need to get your questions into the recording. So I don't want to have to run the mic around. I'm just going to huck a ball at your face. All right, go ahead, Jason.
All right, cool. So today we're talking about OpenTracing with Jaeger. So we'll introduce what both OpenTracing is and what Jaeger is and why we're talking about it and why it applies to the Go meetup and then the Cloud Native, which we're combined with this month. So welcome. For those that don't know, the Cloud Native Computing Foundation is a foundation under which the Kubernetes project is managed and run. Cloud Native belongs to the Linux Foundation. And there's a whole bunch of projects run by the Cloud Native Foundation that Weave uses especially. And so we like to focus on just what those projects are and kind of advertising them a little bit. So Kubernetes, Prometheus, and Jaeger and OpenTracing are all part of the Cloud Native Foundation. And then Utah Go, it's everyone's favorite programming language, and so we love it. Interestingly, a lot of the projects in the Cloud Native Computing Foundation are written in Go. So Jaeger and Kubernetes and Prometheus are all written in Go. So it's really interesting how much overlap there is between the two different groups. Mentioned some of the Cloud Native Computing Foundation projects. You might recognize some others on here. GRPC is part of it. Envoy is part of it. And so the Cloud Native Computing meetup will be kind of rotating through these different projects so we can learn more about how to use them effectively in our cloud-based infrastructures. So distributed systems and microservices are awesome. We all love them. Seems like a lot of people are talking about them nowadays, but there's a dark side to them. Anyone that's worked with large systems of microservices has probably run into it. And the dark side is that they get really complicated really, really fast. As the number of services that you have in your backend increases, it becomes harder, more time-consuming, and just a lot more complicated to understand what's really happening. And when someone comes with a bug report, it's like, okay, this request hits at least 4 or 5 services that I know about. It may hit some others I'm not sure about, and it might take a long time to really diagnose what the root cause of your bug is. So there's a lot of tools that we can have, that we do have to help us with that. We have aggregated logging, so collecting all the logs across all of our services. Metrics and alerting, so we can kind of monitor the behavior of each individual service that's running. And then distributed tracing, which is the topic for tonight. And so it's interesting because logging is geared at kind of the service level. Metrics and alerting are kind of statistical measures. Then distributed tracing is a kind of a per request. What happens to this request when it comes in and where does it go? And gathering information on a per request basis. I stole this really poor quality image from someone from Netflix. They were talking about their microservice architecture, and this is kind of their dependency chart. It looks really, really ugly. Even if it wasn't blurry, it looked just as complicated. So imagine trying to debug an issue in that type of architecture. It'd be really hard without the proper tools. Mentioned that distributed systems are hard. You have your code in all sorts of different places. The way we do it at Weave, we have a separate repository for every single service. So we have probably 100 and something repositories. And so even finding the place where the code lives is hard. Other people are doing monorepos, which are fun and exciting, but they have their own problems. And so, yeah, so back to tracing. We're going to track our individual requests through our system. We're going to get insight into what's happening. We're going to find out where is the time spent on this request. Is it in service A, B, or C? Oh, we might discover it's talking to service E as well. And we're going to get some valuable insight. So before we get into the actual implementation of tracing, we're going to talk about OpenTracing. Instrumenting code is really hard. It's not fun. It's tedious work. If you're going in, taking legacy apps and trying to instrument them, it's kind of painful. So coming and saying, hey guys, hey team, I want you to implement tracing. We're going to put Zipkin tracing into our system. It's a big commitment to go into all your code, to every endpoint, to every client that you have, and make sure that you're adding this instrumentation to it. And then imagine 6 months, 9 months, 12 months down the road, your CTO, who likes to change his mind a lot, says, hey, you know what, guys? Zipkin's a Java app, and we don't like it anymore. We want to switch to Jaeger. It's the new hot thing. Imagine going through and re-instrumenting all your code all over again, right? It'd be a nightmare. And so OpenTracing is an open standard for tracing. So it defines a common API that should be able to support most tracing implementations, and provides a way to instrument your code so that you only depend on the OpenTracing API, and then you can plug in your actual tracing implementation in one spot in your code to provide the actual tracing implementation. But all your instrumentation is using this standard API. So it kind of provides you with no vendor lock-in. If you want to play with different tracing implementations, you could plug in 3 or 4 different tracers and compare them and see how they work without changing your instrumentation. And OpenTracing is part of the Cloud Native Computing Foundation, so they have a lot of support. So it's not going to be something that kind of just disappears and fizzles overnight. So this image here kind of illustrates the role that OpenTracing plays. It's an abstraction layer between the tracing infrastructure and our services and code. And so by making all of our services and code go through OpenTracing, we can actually plug into all the different tracing implementations. So it kind of decouples our instrumentation from our tracing, which is pretty awesome. There's a whole bunch of tracing implementations. Zipkin may be one of the most popular ones. Has anybody used Zipkin before? Zipkin. Jaeger, has anyone used Jaeger? Okay, got a few handfuls. Stackdriver, I know Derek uses Stackdriver. Hawkular, Lightstep. There's all sorts of different tracers out there, and OpenTracing has support for all of them, which is really cool. So what is a trace? When we're talking about tracing, what is it? A trace is really just an abstract idea of a collection of spans. So they're not a trace isn't a real thing that we're storing in a database. It's just a collection of these spans. The span's kind of the real measure. And the span has a lot of properties on it. It has a name, a start and end time, it has tags, it has logs, it has baggage, and it has references. And so the spans all reference each other within a particular request, and together that collection of spans is our trace. And so if you have a request that comes into one service, it'll generate a span. The outgoing request from that one to another service generates another span, and then kind of they daisy chain together until you get your full chain of trace or spans to generate your trace. And so we can kind of see that here. So your main request A comes in, it kicks off request B, which kicks off C, D, and E, and then A is able to finally return its response to the client. And so even just looking at this illustration here, you can kind of see that request C and D has to happen in a serial manner. And then after B is done, then E can run. And so you can kind of get an idea of how your app is behaving and if there's any optimization opportunities. So Jaeger is a project that was formed at Uber. For whatever reason, they weren't happy with the existing tracers and they wanted to do something. So they decided to write up their own tracing implementation in Go and called it Jaeger. And the same people that built Jaeger are the ones that built out OpenTracing. And I imagine when they were deciding to move away from whatever they were using, they ran into the pain of switching. Like, okay, if we ever want to do this again, we're going to build this abstraction layer for us. Both these projects are part of the CNCF. Jaeger's compatible with OpenTracing. It's written in Go. It's very Kubernetes friendly. It was kind of built with the idea of Kubernetes in mind. It was just open source this year, and it's slowly gaining popularity. So Jaeger is a whole collection of different pieces, and it really comes down to probably 4 main parts. So we have our primary storage. You have to have some type of database. So in this case, they're using Cassandra. You can also use Elasticsearch for your storage. You have a collector, which is going to collect spans coming in from all your different services. You have an agent, and in a typical Kubernetes deployment, you'll have your agent running alongside every single one of your services inside of the same pod. If you're on a VM, it would run on each VM as well. And then there's also a query agent, which talks directly to the database, and that's how you can visualize your traces and see what's going on. And then in your application, you have your instrumentation, which is going to hook into the OpenTracing API, and then the Jaeger client plugs into the other side of the OpenTracing API. So the OpenTracing kind of bridges your application to Jaeger. Yes? Oh, yeah, we got to wait for the ball.
Yes.
Ooh.
We got to use it.
Okay, in Kubernetes, does it run as a sidecar, or does it, the agent itself, that's like a sidecar, or is it?
Yeah, so the typical deployment would have it as a sidecar. And so there's pros and cons to doing that. A lot of people run as sidecars, other people run as daemon sets, so it's running on every host, and they each have pros and cons. So at Weave, we're running it as a sidecar in our containers. This chart is kind of showing what happens when a request comes in. So your inbound HTTP request or GRPC or whatever comes in through your instrumentation layer, your middleware. OpenTracing is going to grab it there. It's going to be handled by your handler. And on the way out, the instrumentation is going to kind of wrap things up, gather the timing information, and then send it to the Jaeger client library. And once that's all gathered, it'll send it to the Jaeger agent, and then the Jaeger agent will send it to the collector. And so the OpenTracing is kind of it's a wrapper around the whole request lifecycle. So Jaeger, it's very cloud friendly. So what does that mean? One thing is that they make it really easy to run in Docker. So there's an all-in-one kind of example that they have. And with this big old command, we can run it, and it'll spin up the query agent, or the Jaeger agent, the query part, and the collector all together, and expose that. And if you do this all in one example, it's going to use an in-memory storage. And so you have to be kind of aware of that. It's like it's not going to be writing to disk or anything. So if it goes away, all your trace data runs away. So actually getting it set up in a way where you're going to be storing all your data means you need to set up Cassandra or Elasticsearch and then configure the individual components to point to them with the right credentials and whatnot. So for our demo today, we're just going to use this all-in-one Docker container that they have. Cool. So I'm going to switch gears here. I already have the, let's see, Docker. Okay, so I have the Jaeger all-in-one container running. So if we just go and look at the UI for it, you can see that we have a search bar on the left. And if we drop down the menu, we can see the different services that this instance knows about. We can click on one of them. Let's click on front end. Click on find. There's nothing there because we haven't run anything yet. If I click in the last 2 hours, there's nothing there. Okay. If we switch to our Weave stuff that we have, you can see a whole bunch of traces. Let's go back and just kind of. So here's kind of the search screen. It shows a whole bunch of randomly sampled requests that we have, and then you can click into them. And you can see the spans, a list of spans, and then you see the timing information for each span. And if you click on each span, it'll expand out. You can see that this request was an HTTP put. You can expand the tags. You can see what the URL was. You can see request IDs, the response status code. You can see what other things it kicked off. You can see it kicked off a GRPC request. Later, it kicked off a HTTP post through a different service. And you can kind of get an idea of how this request happened. You can see even down here, we have it hooked up to our NSQ queue. And we can see that it generated an NSQ message, which was picked up later by a NSQ consumer and then processed. And so it's really interesting just to see and visualize what this one incoming request, what it actually did. Yes?
Oh, sorry. I'm not doing my job.
I'm curious on the NSQ, is that a synchronous? Isn't that normally going to be asynchronous?
Yeah,
like,
yeah,
why would
yeah.
it be in this trace?
So a lot of how we use NSQ at Weave is for kind of asynchronous. So that all of our processing is temporally local. So within a few seconds, all of our messages get processed. So we don't have long-running batch jobs where our queues get backed up for a few hours. And so for the ones that are temporarily local in time, so they occur similar in time, we just include them here because it's nice to visualize what's going on. Traditionally, you may not want to do that, especially if you have large batch jobs that are spread out where they get injected and a few hours later they get processed or whatnot.
But some companies do even like event-based processing for everything. So it might go through a message queue even just for HTTP requests, right? And so they still want to check their latency even though it may be asynchronous theoretically.
Cool. All right, so I want to, they have a hot rod example that Jaeger set up, and so I want to spin that up if I can remember where that is. Okay. Go run main go. I believe that's the command to get it spun up and running. Just wait a second. Okay. So we have this little repo. It's going to simulate a database. It's going to simulate a Redis, right? Redis? Yeah, Redis. A cache, and then a front end and a back end and some other pieces. And we're going to see what it generates. So we go to port 8080 here. We can click on the button, and you can see this is a car dispatcher. So it's like they call it rides on demand. So it was built by Uber, right? So you can kind of get the gist of why they did this ride sharing thing. So you click on the buttons, and if you end up clicking on it a lot, we're going to see things are kind of going a little bit slow. And so this is all hooked up to our tracing. So we can go over to the UI, and we're going to look at our front end, see what requests we got. The timing on here looks interesting. You can see that at first things were taking about a second, and then all of a sudden they were taking several seconds for the request to process. So we can click into one of them, and looking at it, this trace, there's a few interesting things about it, right? Like, so if I was an engineer working for Uber and I was concerned about requests taking longer, I come in here and I start looking, coming down here, and this trace right here, this MySQL select, that one looks super suspicious, right? Because it had to wait, essentially, if we open it up, we see here it had to wait 1 second to acquire a lock. And so in this code example, they've got it set up to simulate a situation where your database doesn't have enough connections, and so you're queued up waiting for a database connection before it can execute. And so if you were in charge of optimizing this, it'd be like, okay, most of my time here is spent on waiting for that database connection, so we need to go in and optimize that connection.
I'm coming. So is that MySQL? Is that like pre-allocated, predetermined? We're going to monitor the MySQL query for data, and MySQL's reporting that for?
No, so this would be your MySQL client.
Okay. That
would be doing the collecting, unless MySQL has a OpenTracing plugin for it, which would be pretty dang cool, but it doesn't. So at Weave, we use Postgres, and we started instrumenting our client with some middleware to track our queries better, and so we can visualize them also in our tracing. Another interesting thing in this request Come down here. There's a whole bunch of hits to Redis. In Derek's honor, we like to call it Redis, right?
Inside joke.
Yeah. So you come in here and you see there's a whole bunch of requests, and it looks like they're all done one at a time. And when one is done, one is kicked off, right? We know we can do better than that. We probably know we can do all of these 10 or so requests concurrently. So that'd be another optimization opportunity. If you're using Go, it'd be super easy. Yep. And then on the front end, so just with a couple of short things, we see we can probably improve the performance by handling our database connections better. We can probably shave off over a second. And then on these hits to Redis, we can shave off another 25, 30 milliseconds if we were so concerned about it. So that's some of the interesting information that distributed tracing does give to you. Another interesting thing is on this trace, we see that there's these little exclamation marks. It means that there's some errors that were happening. And so you can click in here. You can see that this one says there was a timeout. So if you were doing a bug, if you're searching for a cause of a bug, you go in through your trace, and you can find out where the error is actually happening. Cool. So because this is the Go meetup, you have a question?
Yeah.
Yeah.
So if I am tracing an error, I see in my logs that there was an error. How would I use that to go and find the corresponding trace?
Yeah, so with our tracing, we don't trace every single request. If you're doing 1 billion requests a day, it'd be quite the storage. And so if the prime opportunity for this is if someone comes and reports a bug and you can reproduce it, then you can run a request with a special header to say, make sure you trace this one and attach this tag to it so I can go in and find it. And then you can search for that tag, and it'll pull up the trace for you. So that if it's reproducible, it's a great tool for being able to do that in a reproducible scenario.
And if you use Stackdriver for logging and tracing, they actually connect them, so you can be scrolling through your logs and click directly into a trace. If they're sampling it too, and so if there is a trace for that request, you can. Yeah.
Yeah.
So it's my understanding that ELK at least has the ability, or you can instrument the ability to go back and build traces off of logs. So if you're keeping your spans and stuff in a similar format inside the logs, you actually build traces off of those as well. I haven't played with that yet, but
We also were looking at a way to actually trigger the Jaeger trace if an error happened, at least for what we could. But we haven't done it yet.
Yep. So we're going to look at how do we do this in Go? What do we have to do? What does it take? And so I wrote up a simple Go app. It has an HTTP server, and a GRPC server, and it's a kind of a hello world type thing. So you give it your name, and it'll respond back to you and say, hi, right? So the first thing we do in our app is we register our tracer, and then we're going to set up our HTTP server, set up our GRPC server, and then just block forever. So in a real app, you'd want to have a nice clean shutdown mechanism. Right here, I'm just trying to keep it raw without using too many abstraction layers so we can kind of really see what is the meat of it. If we look at our HTTP file, we see that we define one handler. It's just going to on hello, and it's going to be handled by our hello handler. We're going to set up right here some middleware, and we're going to pass in our OpenTracing global tracer, which is just whatever gets set up globally in the OpenTracing namespace, and then use the default serve mux. So those that are familiar with Go, when you use these http.handle function calls, it's adding those routes to the default serve mux that's built into the net HTTP package. And then lastly, we're going to listen and serve. So open the port and serve our HTTP request on this mux that we defined. And then in our handler, all it's going to do is pull the context out of the request, get the query parameter name, log a message, call another function to get what our response should be, give it the context and name. If there's an error, we're just going to write out an error message to the client. Otherwise, we're just going to write out the response directly out to the user. So we can see kind of what this does, of course. I switched the order of the two right before the presentation, and it broke. Okay. So we're going to look at our HTTP server. And I've got an example right here. So we can say on port 8000, path hello, parameter name Derek. Say, oh, hello, Derek, right? Okay. If we change the name to Colton, it says not sure how to respond, all right? So you're a new employee, you say, it's a hello world handler, what happened, right? This is not what I expected. I don't know where to begin looking, okay? So fortunately we have tracing. So we can go into Jaeger here, and we go in, we look at our example. The name of my service is called Example, very original. And we can look at our request that was logged a few seconds ago, and we're just going to start clicking through. See, there was a GET request that came in, and then there's some logs in here. Okay, that's useful. Our log says calling hello response. This one's interesting, checking if user is blacklisted. There's a blacklist on our hello world thing. Okay, nobody here knew about that, but now we do. Without even looking at any code, without having to dig through a whole bunch of services, because it could be 10 services deep where it did that. We found it. We found out Colton is blacklisted from our service. Brilliant. Okay, so that was good. And then we also see, interestingly, so that incoming request came in, and we see on the outbound an HTTP client was created. It did a post, and it did a post to some report endpoint and said, hey, I'm reporting this user as a kind of a violation for hitting this blacklist. So surprise, surprise, we're logging this off to somewhere, and then you can actually see where it was logging to. So we just gained a whole bunch of insight into our application's behavior that none of us were aware of before. And then there's a whole bunch of logs here. This is pretty cool, actually. So the Go instrumentation, the Go OpenTracing client implementation is really cool. It actually uses the net tracing stuff that's built into Go. So you can see the get connection event, DNS start, DNS done, connect start, connect done, got connection, wrote headers, wrote request. So you get all this timing information for your HTTP request. So if there is something slow happening, maybe it was DNS. You'll see in your log here, maybe it took 5 seconds for a DNS lookup. You can say, it's not my application that's being slow, it's my DNS system that's got issues. And so this information can be super valuable for digging in and seeing what part of the span was being slow on you. And then, so if we go back to our code, we're going to dig in, because now we know that there's something hiding in here for us. So go into hello response, which is in response.go, and we have a whole bunch of stuff that's happening, like a lot more than we expected to happen there. We see there's a function called isBlacklisted, and we go to our blacklist, and we guess what? If your name's Colton, you're not allowed to use our service. Cool. So, so a couple things I want to point out is, so in this response we have this InfoContext and error context function. These are our logging mechanisms, so it can be whatever logger you're using. We had to hook it up to our OpenTracing API. And so if we go in and look at it, we see InfoContext. What it does is it takes the OpenTracing package and it's going to pull the span out of the context. And so the span was injected into the context by the HTTP middleware. And then here we're going to pull it out. If there is a span, we're going to log a message onto our span. And then we're also going to log to our normal logger that same message. And then on the error, we're going to do a very similar thing. There's actually an error helper we're going to use. And so we can also log it. What's interesting so far is we haven't seen any mention of Jaeger. So if we wanted to use Zipkin instead of Jaeger, it'd be super easy to switch out. All we'd have to do, none of our middleware, none of our handlers, nothing knows about Jaeger. It's all OpenTracing. If we go into tracing.go, under this register tracer, this is the only code in the entire project that knows anything about Jaeger. And so we can switch that out for Stackdriver or Zipkin or whatever it is that we want to use to switch to.
Back on the UI, you had, when you made the report of Colton's attempt, you had two, looks like maybe the sender and the receiver both logged that same span. Is that just expected? And
so this is a great question. So I'm guessing you're asking about these two spans in the middle.
Correct.
So I'm not sure what OpenTracing is doing with their default HTTP client. We don't understand the behavior, but it creates one span for creating the HTTP client, and then another span under it for the actual request on that HTTP client. So I'm assuming if you have some weird behavior where the same client is used to make 3 requests, it put those 3 outbound requests under the same client. Maybe, I'm not sure. That's just how the default HTTP client in OpenTracing works. And then this bottom one, it was hitting the same server, and it got a 404 back on our report endpoint. But it's kind of not significant. Another interesting thing, so we see this last span, it happened at 8 milliseconds. You could ask, why did it take 8 milliseconds between the start time right here, when it started the post, to here, what was going on? You go back into here, and you get all your timing information. It was a DNS lookup that took our 7 milliseconds. So if we didn't have to do that DNS lookup, it would have been 7 milliseconds faster. Super kind of interesting, insightful. And then we also have a GRPC server that we have. So there's also OpenTracing middleware for GRPC. The way that gets added, there's a package under a GRPC ecosystem for OpenTracing middleware for gRPC. So you basically add the OpenTracing middleware into your server chain as an interceptor, and then you start up your gRPC server like new, and that'll automatically generate all that server spans for you. And then the handler for our gRPC server is very similar. There's a say hello endpoint or method, and it's going to call the same hello response. So all our logic is encapsulated in that same response, and the gRPC and HTTP handlers are both calling that same place. And then we get our reply. There's a really cool tool that someone made for gRPC helping, just to demonstrate it. It's called OMGRPC. It's a nice UI built around it. You can load proto files into it, connect to your service, and then you get a nice JSON form to fill out rather than having to deal with all the gRPC garbage.
Just to be clear, the author was the one that went, woohoo!
So he's looking for stars on his GitHub project. Yeah, so we can do this. I'm not sure what's going on actually. Let me see if it's running still. What's going on? I don't know what's going on with it. Well, it should be. I'm on localhost. Call drop by. So Troy, what's this error message mean?
I've never seen that one.
Anyway, it's a great, amazing tool. It actually.
Check the trace. Check the trace.
Yes. So no, that's a legit thing. So was it a problem with my service, or was it a problem with Troy's tool? We can go in here, find traces. There's no gRPC traces in here, so we know that the issue is in OMGRPC. Yeah. So I'm going to try and restart it. I'm going to load my proto file in. Server proto. One cool thing about this tool is if you are using Kubernetes, it'll use kubectl to pull in all your kube contexts. You can choose one, and it'll set up an automatic port forward into your cluster for that service, and you can hit it. And then you can use the internal Kubernetes name to talk to it instead of doing it all manually. But we're just on localhost, so we'll try this again. Troy. Cross our fingers. All right, hello, Troy. So it worked. And then Colton, not sure how to respond. OK, we got an error. And then we go back to our tracing, and we have our trace here. And you can see it'll give us the same type of information about what came in and happened. So we see, again, Colton's blacklisted. So that's just kind of demonstrate the two different, at least two different middlewares for it. They've got middleware for lots of languages. Most popular languages have a OpenTracing implementation that you can use and whatnot. Question? Gotta wait.
So they're all hitting that same say hello function.
Mm-hmm.
Is there a way to, like, say, kind of pivot what right now you're just grouped on the top level request. What if you wanted to say, I want to compare all of my say hello responses? Is there a way to do that?
That's a great question. Not sure. I'm sure, so, yeah, I don't know. That's a great question. So the way that Uber has their diagram set up, they have an Apache Spark job hooked up to Cassandra, and they export it, and they're running all sorts of calculations on the trace data. So I'm sure they're doing some type of real-time monitoring of their responses there. Yes? This is fun.
So I'm not sure if this is the same question, but if you were running this in production, even with sampling, you'd have thousands or tens of thousands of traces for each thing.
Yeah.
Is there any way to kind of get a summary trace, or to see if it's shifting, you release something new and it looks different, those kinds of questions?
Yeah, so I'd probably say that tracing wouldn't be necessarily the right tool for the job. It's interesting because there's a lot of overlap between the different tools we have. We have logging, we have metrics, and we have tracing, and they all have overlap with each other. You can generate some metrics from your logs. You can generate some tracing from your logs. You can get metrics from your tracing. But for this type of questioning, really what you're looking at is your metrics. And so your metrics system would be the right place, so either Prometheus or what's the other Go one? Influx. And the tick stack would be a really robust way of monitoring your timing anomalies.
I was just thinking, if you look at any one trace, there might be an anomaly.
Oh, yeah.
A database call takes an extra, 20% or something.
Gotcha.
That if you average things out, then you get more of what's normal.
Yeah. So in a high volume environment, we can, in the UI at least, we can choose our service, and let's just say we want our GRPC endpoint, and we could go through and look at it.
That chart's surprisingly helpful, even at pretty high.
Yeah, it's like this front end one might have a little more information. So this chart is interesting because you see things were chugging along nice and slow, and then there was a nice slowdown event that happened at that time instance, and then everything since then was going slower. So just the visualization is mildly interesting. Okay, let's throw the ball back here. Oh, it's soft. I thought it was hard.
Can I ask a Java question?
Go for it.
Okay. So with Go, you pass around the context, and context already, that's a common practice with Go. How would you do the similar thing with Java?
I'll open the question to everybody.
All right, for me to figure out.
Yep. So OpenTracing has pretty decent documentation for all of their APIs that are part of their repository, and so Java is supported. And I forget, I'm not sure what they're using. Yeah, they've got.
So I can go. You hit the.
You gotta have the ball.
I don't know how you handle the request object in general with Java. I know in other languages you can mutate it, and just the request object itself would get more information as it went through the request that might be there. With Go, it's immutable, so you have to have the context is where you put all the mutable information.
We've used headers too.
could rewrite it in Go. I think the classic answer in Java, which modern frameworks wouldn't use, is you'd pull the header out from your request. So because usually you'd have a span in the header, and then or some sort of information about that, and then you'd probably put it in a thread local because that's the old school classic way of doing Java stuff. And then when you make a request from then on, you can pull out your thread local and use it for your next request.
Cool. So I think I have like 2 more slides or 1 more slide, and then we'll be good to go. So what's really cool about this is all of our middlewares and everything we developed is all OpenTracing specific. Very little of it has to do with Jaeger. We probably have 10 lines of code that has the Jaeger configuration. So it's really cool. So we're not married to Jaeger, even though it's in Go, so we probably are. Jaeger's got some cool features to it, but it is a young project. There's different types of sampling we can do. So in the demo that I did tonight, we use a constant sampler, which is said, make sure you sample every single request that comes in. You can use probabilistic sampling. You can do remote controlled sampling through the Jaeger agent. So you can say, hey, I'm seeing issues with this. Let's just sample everything right now. Or this one's sampling too much. Let's turn it down. So there's a remote control ability for the agent to control the sampling rate. You can do rate limited sampling. And then there's guaranteed throughput probabilistic. So if you have a service that doesn't get hit very often and you're sampling at, let's say your probabilistic sampling is like 1 in 100,000, but it only gets 10 requests a day, you're probably going to say just make sure we sample 1 an hour. So there's those different modes that it can operate in. We talked a little bit about deployment already. Where do you run the agent? We run it as a sidecar in our pods. You can run it as a daemon set. If you're on VMs, you could run on every single VM or whatnot. And then you run your collector or set of collectors outside of it in a separate query instance. And that kind of is the conclusion. So, any more questions?
What are the pros and cons of that last slide?
Pros and cons of the last slide.
Well, kind of the question I have is about half of our stuff's in Kubernetes, the other half isn't. They're in Amazon, EC2 instances.
Yeah.
And so, is there a way that those services? I guess we could just run the collector on each of those instances, but is there an option to push to maybe a centralized collector?
Yep. So what's interesting is that at Weave, what we do is we have all of our middleware just points to localhost because we assume the agent is running localhost with it, and then the agent is what we configure with the different operating modes, and that points to the collectors. And so they all point to a centralized collector.
But you could put the thing that we sidecar somewhere else.
Yep. And you can just hard code in some DNS name. It's interesting. It uses UDP to talk between your service and your and the agent. So UDP is a fun thing to work with.
So, as you mentioned, Jaeger's a young product. Have you seen any problems implementing it when you were choosing Jaeger? What led you there over some of the competitors?
So it was setting it up was easy and hard at the same time. There's not a lot of documentation around the edge cases, and so it made it a little bit interesting to set up. They're missing some startup log messages, which would help in configuring everything correctly. The all-in-one thing runs great, just really easy. You can either run it as a pod or whatever, but it's not production ready. And so that was a little bit rough. And they have some interesting defaults in the code that need to be configurable. They have some really, really short timeouts for connections. So if you're going between the east and west coast for stuff, you'd run into problems with timeouts. But other than that, it's been super solid for us.
We didn't have a lot of experience with Cassandra, so that was a little bit of a pain, right? So we never installed it anywhere. So we were just, I think we installed it before they released the documentation.
Yeah. It got released in April, and it was May that we started installing it, or June. Yeah.
Anyway, we just sat there going through a step at a time. Now it's a little bit better.
Yeah.
But if you're familiar with the storage backend, we'll do much.
Yeah.
Hey, as long as you're honest about it.
So yeah, we're running it in Kubernetes. It was built for Kubernetes. It's all the support's there for Kubernetes running.
We like cloud native stuff.
Yeah.
Especially if it comes with a cloud native foundation, like we know it's going to run well on Kubernetes.
Yeah. And then just thinking about setting up Zipkin hurts a little bit.
I did, well, I set up Zipkin, and it took up more RAM than all our other microservices combined. That was a no.
Have you done any client-side timings? So there's the whole client performance API that will give you the browser's DNS
Yeah.
request and all that stuff.
No,
Have you looked
we
at
haven't
that
set
at
up anything on the web browser side.
all? How would you even? So it sounds like you can do stuff post-processing. So if you just had like beacons that reported that, you could consume it.
Yeah, you totally could. In this example that they have a whole bunch of, let me see. No, this is all server side. They are not doing any client side stuff on the. I think these are, that's just polling, I think. I'm actually not sure.
I couldn't see any in OpenTracing or in Jaeger anything referencing the DOM.
Yeah, I'm not familiar with that.
It's really, I mean, it's great.
Yeah.
It's like, this is now your servers are good, but somebody in Australia still has a terrible experience because you're
Yep.
not exactly.
Yeah, so in our desktop client product, we've got a shortcut that we can hit that'll tag all the requests, but it still doesn't give us that side of it. But it's definitely an interesting,
For us,
thing
we don't
to-
do anything heavy in the browser right
yeah.
showing data. But that would be valuable, it seems like. We just wire up APIs like Holden. So we just wire up APIs there.
Oh, we do it all day.
Come work at Weave. Yeah. Awesome. Well, thank you very much. Got time for questions one-on-one or whatever. Appreciate it.